After completing this lesson, you will be able to understand structural columns, understand the difference between structural and architectural columns, place structural columns on grid, split columns, place slanted columns, and control the base and top constraints. The objective domains covered are 1.1d, work with structural columns. Structural columns are capable of transmitting compressive loads to other elements that are created below. These could be other elements such as foundations, structural floors, or similar. Revit contains two different types of columns, architectural or structural. Let's now take a look at the major differences of each. Architectural columns are useful as placeholders for architects, as the finished column shape and size may not be yet known. These elements can be joined and materials will merge with other elements such as floors and walls. Structural columns can be placed vertically or slanted and also have an analytical model that's used for structural analysis. A structural column would also join to other structural elements. Go ahead and open up the file 005 Work with Structural Columns. Once the model is open, you'll note that it opens up in the 00 ground floor plan. Our first task is to place some concrete columns on the west wing of the building. On the structure ribbon, click Column. Note on the context ribbon, we have the vertical column as the default placement method. Also note here that we have tag on placement again selected. On the options bar, you can place the column down to a depth of a level, or in our case, up to a height. Here we're going to go ahead and place our columns up to a height of 04 fourth floor. Also note here that we could place the columns unconnected to a desired height that we can enter here. In our case, we'll select the level 04 fourth floor. In the Properties palette on the Type selector, note that the active column is concrete rectangular column 12 inch by 12 inch. As we zoom into grid 5, if you move your cursor over grid 5 and then press the space bar, you will note that the column aligns to the grid. When you're over the intersection of two grids, you'll get the intersection snap. We can then go ahead and place a column down. Note as the column's placed, it's also tagged. For the remainder of the column positions, we're going to use a tool at Grids. On the context ribbon, select at Grids. Go ahead and select the following grids. Any grids that you haven't managed to select with a window, you can add with the Control key held down. Revit will then preview each column on grid. Let's then go ahead and click Finish. The columns are placed out, but you'll also note that the columns have been placed inside structural walls and also out on this grid position here that's not required. We'll just go ahead and click OK to this. We must then manually remove the unwanted columns. So our concrete columns are now placed. Next, we split the structural columns that we've just placed. In order to do this effectively, we'll need to elevate the west wing so that we have a view that's parallel to the columns that we've just placed. To create this view, select the View ribbon and then pick Elevation. Note as we move our mouse over the shear wall, the elevation aligns to that wall. Let's go ahead and place the elevation in this position here. In the project browser, you'll now see that we have a new elevation, Elevation 1A. Let's go ahead and open up that elevation. We can now see the columns that we've placed. If the section size changes as the structure gets higher, we might want to split these columns that we initially placed from ground floor up to 4th floor. To do this, we can select the Modify ribbon, and then we can go ahead and select the Split Element command. Note here that we can then pick to split the columns. Once the column is split, we can then select the column and change the section size as appropriate. If at a later date it's decided that the columns in fact do want to go all the way to the slab, we could delete the columns that we've just split, select the 2 existing columns, and here I could attach top base. Let's select Attach Top Base, and on the options bar you can choose to attach the top or the base of the column to an element. The elements that you can attach to are roofs, floors, ceilings, beams, foundations or reference planes. To demonstrate this, we're going to attach our columns to a sloping reference plane. Click the Structure ribbon and then select Ref Plane. We can sketch a reference plane at an arbitrary angle, then select our 2 structural columns and select Attach Top Base. On the options bar, we want to cut our column, but for the attachment justification here, we're going to select a maximum intersection. Select the reference plane, and you'll now note that the 2 columns are taken up to that reference plane. The warning is just stating that the structural columns are attached to a non-structural target. The columns will now stay attached to the reference plane. If we select the reference plane and we reposition it, you can see the columns are parametrically attached. If we didn't want this relationship established, we could then go ahead and select the same 2 columns here, and I could detach top base. And here I could detach all. I could then go ahead and delete the reference plane. Select the 2 structural columns. Now in the Properties palette, you'll notice that the top offset is differing for the 2 columns because they're raking. So you'll notice here we have a top offset of 16 feet and 9 inches, and here we have another offset of 14 foot and 9 inches. I'm going to select both of the structural columns and set the top offset to 0. Note now they return to the 3rd floor. I can then change the level to 4th floor. Finally, we'll place our slanted columns. Let's change the view back to 00 ground floor, and we're going to go ahead and place a slanted column along grid 2. The base of the slanted column will be on the intersection of the ground floor and this first reference plane. The top of the slanted column will intersect with the 1st floor and this reference plane here. To help us place this column, we're going to first need to cut a section to elevate grid 2. On the Quick Access toolbar, select Section. Sketch a section that's going to elevate grid 2, and of course that remains parallel. We can then change our view depth, and then go ahead and open up section 1. Of course here you may need to change your crop region. We can now see the intersection of the ground floor and our reference plane here, and our 1st floor and this reference plane here. Feel free to change this scale, and also we'll change the detail level perhaps to fine. We're now ready to draw our slanted column. On the Structure ribbon, select Column. Note in the Work Plane dialog we have to specify the work plane where we want to place the column. Let's select Grid 2. On the Context ribbon, you'll note that the Slanted Column option is selected automatically. If we're not in a plan view, then it's assumed that we're placing a slanted column. In this example, I don't want a tag on placement, so I'm going to select tag on placement to remove that option. In the Properties palette, I'm going to make sure that I have my HSS round column selected. I'm now ready to model the column. So I'm going to attach it to the intersection of ground floor and the first reference plane, and then the first floor and the outer reference plane. The warning here is just saying that some of the slanted columns will not be shown in a graphical column schedule. The column schedule can only display vertical columns. If we now return back to our ground floor plan, you'll now note that we have our slanted column placed. We can then copy that to the other two grid positions. Go ahead and select the slanted column. Select Copy. On the options bar, check Multiple. And we'll place down the new slanted column on grid 3 and grid 1. Again, we are warned that these columns won't show in a graphical column schedule. Let's go ahead and open up the 3D view, and we can now see those columns placed.